linear velocity, so we know d omega of y equals 3 meters per second. It takes 100 seconds to complete a lap of the track, so what is that? No? Okay, I think we can get there. What? One revolution equals 100 seconds, so we could get, a revolution per second or a revolution per minute or something like that if we wanted to. From where he starts, it takes him 62 seconds to reach the southernmost point of the track. After running for 33 seconds, at what angle is your reading? Yeah, it does matter because we know it takes him 100 seconds to go all the way around, and we know that it takes him 62 seconds to get right to you. So that's going to determine, so that's actually the first thing that we're going to do is figure out where he started. Do you want to do that? You said proportion. Yeah, so what proportion would you use to do that? 300. Oh, okay. All right. So there's stuff there that we didn't start. Caleb put a couple of these pieces of information and figured something out about the track. You want to do that again? Okay. Want to catch that? If he's going, it takes him 100 seconds to go all the way around, and he's going at 3 meters per second, then that means 3 meters per second times 100 seconds means that the entire track is 300 meters. Okay, so what do we do with that? Keep going. Proportion. We're doing proportion. So 100 seconds to go 300 meters. So we can use that to figure out 52 seconds to go X meters. 186 meters? No, that's right, because it was time. Okay, so that means in 62 seconds he goes 186 meters. So he's 186 meters this way, right? And so he's going clockwise. So yes, I'm sorry, so I drew that in a confusing way. So if he's starting here, we know he gets to the southernmost point. So we're just trying to figure out where he starts from. So we have to figure out where he started. How do we do that? If we know that he went 186 meters and we know the whole track is 300 meters. Yeah, so what's proportion of the angle to right? Okay, 300 over 360. Because all the way around is 360 degrees equals 186 meters over X. So what do you get from that? That's going to give us this angle right here. 222.2. Good. Okay, so that means now we can take that because we know where he started. He's running for 32 seconds at what angle is Yuri, so we're going to go proportion again. What's the proportion you want to work with? Okay, so in 62 seconds he goes 223.2 meters. You're fine, so keep going with what you got. Equals. So in 33 seconds, how many degrees does he go? Okay. What'd you come up with? 118.8. Okay, so your answer would be 118.8 degrees from the starting point. Does that work? Okay. Tatiana. What? I know how to run too. Tatiana starts running at the same time as Yuri starts running. Tatiana starts from the westernmost point of the track. She's over here. She takes 90 seconds to complete a lap of the track. When will she pass Yuri for the first time? She's going the other way. So she's going this way. Yuri's going this way. When will they pass for the first time?
I don't know how to, so it's in 5 minutes. So I don't really know what to do with it.
Honestly, 90 seconds?
Well, I'm like,
I don't know. We can send a number on it.
well, let's see.
Both of them. No, because they're not gonna.
It takes her 62 seconds to get to the start of my time after I start. Wait, it takes her 62 seconds? No, it takes Yuri 62 seconds.
Right, how do you know? Okay, so I'm gonna try to think that first. No, I don't think so because they're not gonna do a whole lap until they finish. So it's not gonna take a minute. Oh, I see. Like, can you do that? Can you try that a little bit later? Yeah, can you try it? And see if you can do it. Try to figure out how many other things to do. So do that and see if you can get it.
Takes Yuri 62 seconds to get to the start of my time.
Right? So what?
Write that all down.
We don't know that they're necessarily gonna meet there, right? I think Caleb is sort of on the right track. Since they're going.
I don't know who's coming out there.
Yeah, so we're trying to explain. She's trying to explain. If they're going towards each other, what is their like? How? At what rate is the distance between them changing? 190 seconds per entire revolution. So they're going at each other. Right? So like if you have.
It'll be in a track.
Yeah, right. So if you're in a car, you're stationary, and you're going, this is going 60 miles an hour, but if you're going at each other, then your distance is both going at, speed, okay? So this distance is changing at 190 seconds per 300 meters.
So you just go 190 per X and you would.
Do you know how long it would take to cover the rest? Okay, so what Caleb is saying is, this is good. We figured out this whole angle right here is 223.2 degrees, right? And this angle right here obviously is 90. So they have to cover a total angle of what? How many degrees do they have to go through together? 313, right? This 90 plus this 223. Okay? So they have to do 313 degrees. How long is that going to take them? It's going to take them, how long is it going to go around the whole thing? Isn't it 190 seconds to go around the whole thing?
I'm trying to keep them.
Yeah, that's not that much. Oh. Alright, let's try that. So Caleb is going to take this into a distance using the fact that 350 degrees is 300 meters. And then that'll tell us what distance they have to go.
I would.
Yeah, I'm still stuck on the
Not a question.
190 part.
Yeah, I'm stuck on like how do you.
Forget what we got going here.
No, not really.
No, not really.
So the 223.2 and the 90, how do you know that's what you're like, how do you know they're going to meet on that airplane?
Oh, we don't. No, we don't. What we're trying to figure out is the total distance that they would. Yeah, we don't.
Okay, because I was thinking they were going to do it that much.
Right, we're not going to. No. Yeah, he starts right here, so we figured that out. And she starts right here. So we're going to try and figure out the total distance that they were going to go together. No, because he started right here and going this way. She started right here Did you figure out what that distance is? Okay. So Taylor figured out using this proportion right here, the length of this entire arc is 261 meters. You good with that? Yeah? Okay. I feel like the proportion is like, isn't it going to be 9 over 10? So 2 goes to the 90 seconds, so 2 goes to the 10. Oh, we got to divide it by 19 seconds. Hang on, we'll figure it out. Huh? Yeah, because it's Thursday and the phone is going to last week. I want to put it into, you want to divide by 190? And then so 2 does 9 of those and 2 does 8 of those? And 2 does 100, 2 does 2 does 90? Yeah. Yeah, I don't want you guys to stress about this. Okay, so we have this distance, so here's what I'm thinking, is that he's going to do 90 of it and he's going to do 100 of it. So it's kind of like if you have, when you were little and it said, you have two numbers and the ratio is 3 to 2 and they add up to 50 or something and then you have to figure out what the two numbers are. So you go, if I take 50 and divide it by 5, then this piece is, if I do that divided by 5, then that's 10, so then this piece is 30 and this piece is 20, almost like that. No? Does that make sense for us? But what I'm trying to get at with this, and some of you aren't following me here, so I don't know if you can get this. You kind of get this thing here. If you have a amount or whatever and you know the ratio, the way that you can find how much each piece is by dividing by the sum of these, and then this person gets 3 pieces of it, and then it's 2. Okay. That doesn't make sense to you now? Okay, so, go ahead.
Okay, so I get like what the, I get what's going on with it there, but I wouldn't know like 3 to 2, there's 5. I got 5, where did you get the 6?
Where do I get the what? Oh, it just made it up.
Oh, you just made it
Yeah,
up.
just made it up. So the 3 to 2 and the 50 are just made up. Okay, so you can do it with anything, just give me another
Okay,
ratio.
so I said 4 to 7.
4 to 7, and how much money do you have altogether?
110.
Okay, so you got $110. Oh, that's good, because these two add up to 11. So that means each piece is worth 10. So if you get 4 of them, you get 40, and you get 7 of them, so you get 70.
Okay, see, that's where was this trip when I was in the 4th grade? I didn't know that you have the 3 numbers and then you had this.
Okay. We do. We figured out the distance that they're traveling is 261 meters. And so we know, and we know that their speed added together is 190. So if you do the same trick, you take the total distance divided by their sum, that means that each piece is worth 1.373 meters. Okay? He's going to have to do 100 of those, which is slow, so he goes this far. She has to do 90 of them, so she goes this far, and then you can use that to figure out where those is. So you know where these are. I'm sure there's another way to do it, and like I said, I feel bad that we kind of this is all muddled, but don't worry about it. I'm not going to ask you a question like this on the midterm, but in case you're curious about how you do it. The ratio one? No. Okay. Two things are in the ratio of 4 to 7, and they're at 400. Okay. All right, let's try a different one. All right, so number 8 says the people of a certain country are working to improve the literacy rate 100 for A, 0 for X, 0 for X plus B. Okay? That's good. Unusual attitude. Not being so nice all the time. Are you Canadian, Casey? Okay, so you guys get where these two equations come from? Everybody in the room gets that? Okay, so then you can cross multiply. Of course, this is going to be 0 and this is going to be 0. So this just means that 50C equals V. This works out to be 1,000. So if I cross multiply this way, I get 750 plus 75C equals 1,000 plus V. Yes? Yeah. Okay, and then you, since we know B equals 50C, I would just substitute that right in there directly. So 750 plus 75C equals 1,000 plus 50C. So, yeah, 25C equals 250, so C equals 10. B equals 500. A equals 100. So, basically, you guys love these, right? Huh? One of the limits? Well, this is a great example of a limit because this is a function that if the limit is 100, then we'll never actually get there. So that's how it is. Yeah. Okay, so there is our equation, right? Okay. Alright, so then it says to find the inverse. Okay, do you have this written down somewhere? Okay. Maybe you tell me what it is. Equals y. Okay, so the inverse is switching around, right? Okay, so 100y plus 500 equals y plus, or over y plus 1 equals x. Okay. Any guesses? First step? Good. That's a great instinct. Get rid of those stupid fractions. Nobody likes fractions. Not even Casey, who seems really pretty polite. Yeah, prime number. Right? Okay, then you just have to remember that math is basically rooted in racism, so you want to get everything on one side and then everything else on the other. Okay, so what are you trying to solve for? Okay, so everything that has a y in it goes to the left. Or the right, but I'm going to go to the left. Everything without the y in it goes on to the right. Okay? So xy minus 100y equals 500 minus 10x. Because you're always separating things. Variables on this side and numbers on this side. Yeah, so now you back out a y. That is x minus 100 equals 500 minus 10x. And then you divide by that. Not your inverse. Yeah, you had it because you said factor, right? So you were on the right side. Okay, that's okay. another. Let's try another one of these crazy things and see if we have any better luck this time. All right. Okay. Hello. Okay. Good. Jurgen. Okay. Cameron, we good? Yep. Okay. Okay. All right. So Jurgen is running clockwise around the circular track once again. From his starting point, it takes him 14 seconds to reach the westernmost part of the track. So it's going to take him 14 seconds to get to right there. It takes him 80 seconds from his starting point to reach the northernmost part of the track. No, he's running clockwise, so he's starting somewhere over here. Probably like pretty close to this point. Right? So
why is it taking so long to get back then? Because when you start getting close to that point, it will say.
Yeah, so he's starting to go closer, it will take him 14 seconds to get to there, and then another 66 seconds to get to there. Starting point. Okay. And senior proportion here could just tell us already where he would start. Looking at that information right there. You guys see how you do that? You could say 66 seconds to go 90 degrees, so 14 seconds to go how many degrees?
The other day, someone was trying to tell somebody that I was doing like 86. I mean, it's like, I got it after you kind of like, come on.
When we were in Morocco, I think we were shopping, and the person started to talk to us in English,
Right.
and then my daughter speaks my language, so she would start to talk to us in English.
That happened to me.
And the shop owner didn't do that. Whoa.
We had a shop owner that really mad at us sometimes if we started speaking like crazy fast. And we're like,
So now if you use that as a trick, it'd be like, oh, she speaks so good, we give you good price. Anyway, so what did you come up with? 19.09? Can I go with 19 degrees? Okay. So that means his starting point right here is 19 degrees from the negative x-axis. Okay? Is that alright? Yeah. Okay. Okay, he runs at 3 meters. What? He runs at 3 meters per second. His velocity is 3 meters per second. So once again, you can use this to figure out the circumference of the track. I don't know if we need that or not. I'm not really sure. I'm just going to get all the information that I can out there before we start answering the question. If it takes him 66 seconds to go this distance, and he's going at 3 meters per second, how many meters is it? If it takes him 66 seconds to travel this distance, and he's going at 3 meters per second, what? Nope. 32. You divide.
oh, you lied.
Okay, so this distance is 32 meters. Alright? Means the entire circumference is what? Okay, 128. Okay, so we got all kinds of information here, alright? Okay, so after running for 8 minutes, at what angle is Jurgen? So the first thing that I would like to do is I'd like to change the 8 minutes into seconds. Are you okay with that? Yeah. Okay. So 8 minutes is what? How many? 480. Okay. Okay. 480 seconds. Okay. How long did it take him to make one revolution?
42.
Wait, I don't know. What did you say?
No, what? We did this or not?
distance equals race times time.
Thank you. I thought I was crazy.
You are crazy. I know, I was so confused.
I was like,
Why do I have
everything in physics I've done wrong so far.
Okay, sorry, so you multiply by 3, my apologies, and so the circumference is what? Well, that's not the circumference, that's this distance right here. Okay, so this quarter circle is 198 meters. Good thing I'm not taking this test. You multiply that by 4 and you get what? 792 meters. Okay, so anyway, what was the question? What angle is yours in? Alright, so
I got 254 seconds.
oh, that's what I was looking for. Okay, so 1 revolution equals what? 264 seconds. Alright, so G's gonna go all the way around once. Okay, and then how many seconds does he have left? 216. If I subtract these, then he's got 216 seconds left. We aren't really doing anything with like angular velocity, which I know we're probably physically, but we could just do a proportion again, I guess. If he goes right here, 19 degrees and 14 seconds, what we're basically saying is how many degrees does he go in 216 seconds, right?
Well, if it wasn't a circle in seconds,
Yeah, okay. But I guess, like David said, proportions are pretty easy, so might as well do this. So he goes 19 degrees and 14 seconds, so how many degrees does he go in 216 seconds? We're gonna have to flip one again. 293 degrees. Okay, so you could say 293 degrees from his starting point. You could be cool and figure out like some pauses like that, or something like that. Okay. And then the whole B thing where we're trying to set somebody else and then they pass each other rather than the okay.
actually, I think I did it right. I don't, probably not, but
Alright, where are we at? Okay, let's get one more in here. Okay, number 10. Each of the wheels of a bicycle, so now we're repeating, has a radius of 33 centimeters. The front sprocket has a radius of 7 centimeters. What radius should the rear sprocket have to achieve the forward speed of the bicycle 25 kilometers per hour? Isn't that awesome?
not
Yeah,
wow.
it's really, really beautiful. Go to the next one for sure. Okay, for the forward speed of the bicycle, 25 kilometers per hour while pedaling at. So this bad boy right here, because it's connected to your pedal, is going at 95 revolutions per minute. Right? Okay, so hopefully you guys understand that our problem solving strategy here is to find the revolutions per minute of this rear sprocket and then use that inverse proportion that Mackenzie said she loves so much to figure out the radius of this. Does that make sense? Okay. So the way that we're going to figure out this is we're going to take the linear velocity and we're going to take the radius and we're going to use those to give us an angular velocity. Yes? Then we're going to take the angular velocity and change it into revolutions per minute and then we're basically done. Okay? Alright, so this is in centimeters, the speed is in kilometers per hour. What units do you want to get to? Meters. So the radius is actually 0.33 meters. The velocity is not 25 kilometers per hour, it is 25,000 meters per hour. So if you divide those two, the angular velocity is 75758 radians per 1. Okay. Won't let Jake second. Logan second. He was the one that was using it. Let's
So I
get
was
Logan.
doing something right. I think I just got the that.
No, you don't do it. Okay, so how many times faster is this one than that one? Yeah, 2.12 times faster. Okay. So that means that this sprocket has to be 2.12 times smaller. Smaller. The battery. Okay. So then you take 7 and divide it by 2.12 onto the whole.
Is that like why do we have to do that?
Because it's that inverse proportional either. That one's going to go faster. Yeah, divide 7 by.
I had it right, I just did it the wrong way. I did it backwards.
Okay. What is the function? 3. Okay.
But if I had it, I had all that, but I made the 95 out of 6.
Okay, so we're repeating, right? Like I said, we're doing these problems, we're doing some circular graph ones. Oh, okay, so maybe tomorrow should we jump to that? So my suggestion would be then to you that you would do some of these on your own. So this one is the linear one, that's easy. This is a population one, that's easy. This is an exponential function one, that's easy. Okay, that's an exponential function, that's easy. Exponential function. So you're talking about these right here, Brooke? These right here? Okay, so we can start in on those tomorrow. Okay, what? Which one? You want to just dive in? Oh, we're up till 20, huh? Okay. Okay. Sure, so we can knock off a few of these. So let's do this in standard form. So how do we do this in standard form? Do you remember? Do you remember what standard form means? It's easy. All be accepted. Okay, so we don't have a number to the x, we have a number to the negative x over 4, so how do we change that to a number to the x? Yeah, so you can rewrite this as 81 to the negative 1/4 of the x. No, it would be 1 over 81 to the 1/4. We can just go calculate it from here with 81 to the negative 1/4. So 1/3. And just 1/3 is 81 to 3, so that's really 1/3 of the x. We always try to accept it. B. Okay, so same deal here. This one was easy to rewrite it as a thingy. What do you do with when you end up subtracting it? Divide it. So we'll rewrite this as 11 over 0.819 to the 3x divided by 0.819 to the 4. Make sense? We're going to do that eventually. Does that make sense? No, it's just 4 because you would subtract the exponent and it would make it 3x minus 1. Okay. So what do you do when you're dividing a number by a fraction? Inverse. So we're going to do 11 times this is a little bit maybe mildly, yeah, this is a little mildly confusing, but I'm really going 11 times 0.819 to the fourth times 1 over 0.819 to the third
Yeah,
power.
oh my.
So what's 1 divided by 0.819 to the third? I got that. It's 1.26. Did I say 1.82?
Yeah, you did.
Go to the page. 1.82? I did. I just got it. Okay. How do you feel about that? Not so great?
No, I don't like that.
It's okay,
It's okay?
it's not bad.
Here's what I'm gonna tell you though. These problems, I don't know why we do them because we're preparing for calculation and we're gonna do them. So we're just gonna not do them. It's not. That's fine.
What all the laws and stuff like that.
Yeah, let's see what else we got. Same dealio here. We're not ever gonna mess with changing this to a base of e out of y, whatever. Do that. Okay. We don't need it. Okay, this, yes, we should be able to do. So let's try this.
8 to the third to the x.
What?
Well, I did, yeah, do that.
Hey, can we not just figure out what 8 to the third is? Yeah. 4 times 8 is 512. Okay, so this is really just saying 512 to x equals there you go. So how do you solve that? You do, yes. So you can always both sides. You can rewrite it as x squared plus 512 equals 16. So x equals the natural log of 16 divided by the natural log of 512. Nice and got these problems or you just think so? If you want to, you can go 8 to the third to the 0.434 and see if you get close to 16. Trust it. Alright, how about B? Okay, so there's two ways you can do this. You can use the old-fashioned simple base formula and go log of 8 divided by log of 3, and that would give you the answer. Or you can use the simple simple calculator and go alpha f2, and then number 5 is the log here, and so this is log base 3 times 8, and that will give you the 3 to the 1.8 minus alpha what? Alpha f2, and then number 2, 5. Or like I said, if you don't want to try and remember that, you can go log of 8 divided by log of 3, and that will give you, yeah. Alpha window, I think. Yeah. Okay, so let's write that down. So this is really just 1.89 equals log base 7 of 2x. No. What's the definition of log? What is the definition? What's it all about again? Why are we doing this? What's the meaning? No. The definition of a log is if this number to this power equals this number. Okay? So from here I would write 7 to the 1.89 equals 2x. And output 19.8. this number is this power equals this number right here.
So why don't you write this down?
Because that's the definition of
What's the 26?
no, it's log base 12 of 25 equals log
But
base
you're
4 of
saying this number is
this
the
number
power.
right here, the base number, in the log function, is this power equals this number right there.
Oh, so you went backwards.
I just went back.
Okay.
Okay. Now you want to then ask your calculator, what is log base 12 of 25? On the calculator? Okay, yours might not have, what happens when you also reload?
Press 5.
That, okay. Number 5 is log base. What minus 12 and 25? So that's 1.295.
So then after that we go 4 and then 1.29 for the rest.
And then, remember we use the definition of logs again, this number and this power equals this number right here. X equals 4 to the 1.
Yeah, I think it's
Okay?